Dee here. I'd like to show you how to use Watt's law in parallel circuits. And Watt's law is P equals I times E. To do this circuit, we're going to first need to use Ohm's law, and then we're going to solve for watts with Watt's law. On the left-hand side up here, I have Ohm's law, E equals I times R. I have red T's in my circuit to represent Ohm's law values. And over here on the right-hand side, I have Watt's law, P equals I times E. And the green T's will be for Watt's law. Down here on the right hand side I have Watt's law. P total equals P1 plus P2 plus P3, etc. And we could also use P total equals I total times E total. Notice that the subs for this are the same. So P total equals I total times E total. And if I was to look for watts for R1, for example, then I would want to use the subs for R1, so it would be P1 equals I1 times E1. Let's throw some values in here. I have some values filled in to the circuit now, and I look around and I try to find two values anywhere. Or I also look for my rules. Remember, E total equals E1 equals E2, etc. So that tells me that if I have 240 volts here, I'm also going to have 240 volts for R2, 240 volts for R3, and 240 volts for my source. So that's great. Now I have a bunch of numbers to work with. If I take 240 divided by 5, following Ohm's law up here in the corner, R equals E over I will end up with 48 ohms. And I can also take 240 divided by 80, which will give me 3 amps. On this one I don't have two numbers, but if I go back over to the source, 240 divided by 26.6 will give me 9 amps, and that's a total, so I know that that 9 amps is coming out of the negative, going through I total, and I have 9 amps right there. 9 amps entering that junction or node. I don't know how much is going down through R1, but I do know that continuing on is enough for the 3 amps going through R2 and the 5 amps through R3. So right here, going into that junction, I have 8 amps. So 8 amps going in, 5 and 3 leaving, which means running down R1, I'm only left with 1 amp, and that's the value of the current through R1. Then I can take 240 divided by 1 amp, which will give me 240 ohms, and I've solved for most of my Ohm's law T's. Next I'm going to solve for Watt's law, so I'm going to use either one of the Watt's laws to help me out here. From my Ohm's law T's, I can carry down some information. Remember, Watt's law was P equals I times E. Now I can solve for Watt's law. I have the green T's here, and I'm going to use the formulas for Watt's law. If you notice, P equals I times E, I can take the values from my totals. 240 volts is my E total, and 9 amps was my I total. 9 times 240 will give me 2,160 watts total. To find the watts for R1, I again can use my voltage, 240 volts, 1 amp. In this case, R1 is using up 240 watts. R2 will also have 240 volts, and this time it has 3 amps, which gives me a total power of 720 watts. And R3 is also 240 volts, but it was 5 amps. In this case, I'm using up 1200 watts. P total equals P1 plus P2 plus P3. I can double check. 1200 plus 720 plus 240 actually does equal 2160, and I know I've done all of my math correctly. Thanks for joining me.